For our 561 project, we chose to use game development software that was much more powerful than anything we have previously worked with. In the past, we've worked with creating two-dimensional JavaScript games and HTML5 games. So we chose to use the Torque3D engine as well as Play Canvas. These two engines give us the ability to integrate the Leap motion controller as well as create three-dimensional games. We wanted to create three-dimensional games because they're more engaging to the user. So in our end game, we created a first-person shooter, a coin collection video game, as well as a game that is controlled by gestures. The following slides will show these three games in detail.
This is Corey. I'm going to be showing you the coin collector game, which I programmed. It's a multiplayer game and is controlled by the Leap. There are two levels, Highlands and Riverside. First, I'm going to show you Highlands and the controls with the Leap. And both of these maps were made using the world editor in Torque. So here's the game. The player is controlled by using your hand as a joystick, moving forward, tilting forward and backwards to move forward and backwards, and tilting your hand right or left to look right or left. You can also jump by making your hand into a fist, as shown there. The point of the game is to collect these coins, and you do that by just running into the coin. And a nice little animation will play to show you that you've collected a coin. The first player to 10 coins wins, and next I'll show you how to implement the multiplayer feature of this game. Multiplayer can be done by clicking the join button instead of the normal play button, which is for single player. Once a game has already been created via the play button, you can join that game over LAN by just clicking on query LAN and then finding the game and playing it. This provides support for up to 4 games currently, but can actually support 64 over the server. Adding multiplayer allows players to play with their friends, which makes it a lot more enjoyable. And here it is, the other player right there. It's a little laggy because I'm running 2 instances of the game. Anyway, as you can see, we've joined the other player's game, and now we can begin the race for coins. Yippee! So now I'll switch over to the other instance and show you that he is indeed a player, and you can move him around. It shows up on this screen as well. Now I'll show you what happens when you have collected 10 coins. I have 9 right now, so moving up, getting that final coin displays the winning message to the winning player and a less fortunate message to the losing players. So this was the coin collector game. In the future, I hope to add a shooter element to this game, as well as implementing it over the web, so that it can be integrated into our rehabilitation system.
I'm Michael Rowack. Okay, so this is the game I created in the Torque3D engine. It is called Nuclear Island. The game focuses on a player that has crashed on the middle of a supposedly uninhabited island. However, they've come to find that it's populated with enemy forces. So the game is a first-person shooter, obviously, and it focuses on a linear flow, I guess, where the player just kind of runs through the map and fights waves of enemies. One of the challenges was creating the artificial intelligence and having it be smart to a certain extent and respond to events such as the user entering its line of sight, and then once that happens, having the AI respond with some sort of action, that action being fighting back or running on a path to join reinforcements and that sort of thing. So in the video you're kind of seeing some of the more action-packed events that I set up throughout the game. I kind of had it scripted so that throughout the game there's triggers that obviously, as it sounds, trigger a certain event. So for instance, as you're watching, the player is running and then he is about to enter the field. That triggers an event, and this event is a bunch of explosions going off, as well as the area being populated with AI. That's kind of running all over the place, and then as the player proceeds, there's a first and a second line of reinforcements that the player has to fight. And then this is kind of happens throughout the map, where it's just based on the location. There's ambushes that can be set or bombs that are going off. And then I also made sure to include things that make the gameplay more fun. So as you're about to see, there's a pickup that I set here. It's more ammo for the gun, but as well as this, it's a grenade launcher, which is, I guess, more fun. So as the player progresses through the level, there's more weapons he can use, like the rocket launcher that you've seen earlier. So now you're seeing the final stand, I guess, which is the end of the level. And this is kind of just, there's a whole bunch of guys, and so it's just kind of, I guess, one of those events that you see in a typical video game, where it's just kind of the finale, I guess, if you will. So once the player gets to the end of the map, he teleports to the top, where I said he calls reinforcements, and then he basically wins the game. That's it.
So in order to improve upon this project, I would improve the AI and make it capable of guarding areas, as well as tracking down the user once it came into their line of sight, as well as adding more levels to the entire game.
Quick demo of the gestures game for ECE 561. It uses the Leap motion controller to control the game. And let's get started. So as you can see on the screen, there are two sets of hands. One hand is the user-controlled hand, and as you can see, it mirrors the motion of the user's hand pretty closely. The hand that's rising up out of the floor is a hand for the user to match. So when the hand reaches the position of the controlled hand, that's when it does like its checks for whether the hands are equal or not. It checks for rotation as well as the open or closed state of a hand. So when it's closed, you can see the closed fist appears on the screen as well. Feedback is given instantaneously through the feedback board on the screen, which is the white canvas square that you can see. As user progresses through the game, the environment actually changes. So right there we just saw a change in the color background. In addition to the color change of the background, the lighting also changes, just to give some additional positive reinforcement. The speed of the hands starts off fairly slowly, as you can see. It almost takes 5 seconds for it to get to the actual hand. This game was developed using the Play Canvas app engine, which is available for free. It's open source license. The API allows for integration of these objects with JavaScript code. So, like the code for the hand is attached through the editor. The developer here almost doesn't have to touch the HTML or CSS code in order to make a game like this, which is quite remarkable. So now we can see in this upper level that the lighting is much more bright. We now have a hook as a playing hand, which adds an extra level of difficulty to the game. And in addition to that, the hands are moving very fast now, and it's difficult for me to play even without any disabilities. And that's gestures. This game will hopefully be an excellent tool for patients who are looking to rehabilitate their hand and maybe gain additional movement in their hand. But for me right now, it's actually just kind of a fun game to play.
So to improve the gestures game, if I had more time, I would add sound reinforcement for when the user matches or doesn't match the hand. A better model for the hand so that it looks more like a real person's hand, to help with the patient visualizing their hand, as well as a way to track the time and the score. The major goal of this project was to explore more powerful software to develop games than we have used in the past. We chose to explore the Torque3D game engine as well as the Play Canvas engine. In the development of our games, we found that we don't necessarily want to continue development with Torque. However, we do want to continue development with the Play Canvas engine. Based on what was done in the Play Canvas engine, we believe we can further create engaging three-dimensional games using the JavaScript and HTML5. And based on this, we believe that the project was a success since we found a piece of software that fits our needs. As well as this, the project was successful when considering that we all developed a game and we gained a fundamental understanding of what it takes to develop video games.